Welcome to lesson 22, graphing linear inequalities in two variables, meaning x and y. First, I want you to press pause and copy the learning targets into your notes. So let's get these learning targets into our notes. Press pause. Okay, so what are we looking to do here? Given two variable inequality that represents a situation, I can interpret points, right? We're going to be able to interpret points in a coordinate plane and make a decision if they're solutions. We can find solutions, right? So we can find them by using a graph, and then we can write inequalities to describe the constraints of the situation. So interpreting points and deciding if they're solutions, finding solutions, and then writing inequalities. So our opening situation has to do with landscaping. And I've had some landscaping done at my house. I do most of the work on my own, but I had some landscaping done and it was extremely expensive. And so a homeowner is planning to make some landscaping changes in her yard. She's going to hire professionals, right? So she's got some grass sod installation. That's going to be $2 per square foot. And then there's the flower bed installation, and that's going to be $12 per square foot. So that's the cost. And her budget is $3,000. So the first thing says to write an equation, right? So when I think equation, I think equals. And when I think inequalities, I think less than or greater than, less than or equal to, greater than or equal to, right? So inequalities versus equations. So write an equation that represents the square feet of grass sod and the square feet of flower beds, y. So since x is the grass sod, and that costs $2 per square foot, 2x plus the $12 for the flower beds, which is going to be y, is equal to $3,000. Now, the next thing they want me to do is to graph this thing on a coordinate plane. Now, I don't think that this is really in a good situation to graph. So one thing I could do is I could solve this in terms of y. Now, one thing I could do is I could rewrite that, right? And solve that in terms of y. So I get y is equal to 250 minus 1/6 x. But that's going to be really hard to graph on this particular graph because the y-axis doesn't go by singular values. So that's a real toughie. I think what might be more valuable is to graph this using x-intercepts and y-intercepts. Remember that my x-intercept is the value of x when y is 0, and the y-intercept is the value of y when x is 0. And to get those values, what I'm going to do is substitute in 0 for x in my original equation, solve for y. I'm sorry, that's how I'm going to do my y-intercept. And then for my x-intercept, I'm going to substitute in for y, 0, and solve for x. So what happens to this equation when I substitute in 0 for y? I'm going to get 2x equals 3,000 because 12 times 0 is going to go to 0. And conversely, when I substitute in 0 for x, I'm going to get 12y equals 3,000. Now I know from doing the conversions for my slope-intercept form here that 3,000 divided by y, or 3,000 divided by 12 is 250. Versus over here, 3,000 divided by 2 is going to give me 1,500. So 1,500, 0 is my x-intercept, and 0 to 50 is my y-intercept. So now I'm going to plot those on my graph. Now before I go doing this by hand, just for the record, I don't think it's a bad idea to throw this into Desmos, right, and take a look. And what do you notice? It looks like this is 500, and this is halfway, which that would place that at about, you guessed it, 0 to 50. And over here, looks like 1,500, 0. So we're doing pretty good. And so there's our line, or a rough sketch of the situation. Okay. Again, notice 0 to 50. 1,500, 0. And so at this point, just keep in mind what we just did. We just reviewed a whole lot of stuff from past performances, right? This idea of being able to write an equation, translate it into slope-intercept form, or write an equation and solve for my x and y intercepts. You mean to tell us that we need to be able to hold on to that into the other future lessons? Absolutely. Now, out of curiosity, let's take a look at the point that I have the arrow drawn to. That has a coordinate of x of 600 and a y of 150. Now, they're not all nice coordinates, but what does that point represent? Well, that represents 600 square feet of grass sod and 150 square feet of flower bed. So it appears that the more sod that this lady orders, the less amount of square footage of flower bed that she can afford, right? So it doesn't give her a name. I find that funny. They usually give a name. But anyway, as we move down the line, this represents an increase of grass and a decrease of flower beds. As we move in this direction, or I should grab another pen. As we move in this direction, we're getting less sod and more square feet of flower bed. So there's a trade-off, right? You can't have, as they say, your cake and eat it. You're going to have to make a decision. So the next conversation is kind of cool, right? So the homeowner's thinking about, well, hey, listen, if I have a flower bed, you got to maintain that every year. Some of you may spread mulch with your parents and do some lawn work, right? And you got to mow the lawn, maintaining grass. So now what she's doing is she is considering the idea of artificial turf, which costs $15 per square foot to install, and then just gravel instead of the flower beds, right, which only cost $3 per square foot. So she may use a combination of two materials in different parts of her yard, right? And the budget is still $3,000, right? So here's the new line for that idea. Okay, so it says the graph shows a line going through 500, 100. And what does the point 500, 100 mean? Well, 500 refers to the x value, which is 500 square feet of gravel, and the 100 is the y value, refers to 100 square feet of artificial turf. Now, if you take that 500 square feet of gravel and multiply it times the $3 per square foot it costs, and that'll give you $1,500. Then you give the 100 square feet of $15 per square foot of turf, another $1,500, and 15 twice is $3,000. That equals the budget. So in terms of an equation, we'd say that's a solution to the equation. Well, what equation? Oh, well, X number of square feet of gravel, because this is going to be our X and this is our Y, times 3, add that to the $15 of cost times the square foot of artificial turf, that should yield us $3,000. So 500, 100 is a solution of said equation, right? And what do the solutions to the equation mean? They're all the possible combinations that yield us $3,000. Right? So again, you might just want to press pause and put that into your notes, right? The points on the line represent all of the possible combinations of gravel and artificial turf that yield us a cost of $3,000. And again, nothing new to see here. We've been through this discussion. But what are these other points? Again, I just want to rethink about what our learning targets are here. Interpreting, right? Interpreting. We're here to interpret what's going on in real life. So the point 600, 200, as I'm looking at that, that's way up there, right? Above the line. And the question here asks, does that meet the constraints of the homeowner, right? Essentially, are we going to land at $3,000? Well, 600 is the X. Gravel costs $3, so 600 times 3, plus the 200 is the Y value, so that's going to be 200 times $15 a square foot. What does that give us? Well, 600 times 3. 6 times 3 is 18, so that must be 1,800. And 2 times 15 is 30, plus the 2 zeros, so that's 3,000. Whoa, $4,800. So does that meet the homeowner's constraints? No. No, no, no. Our answer is no, but this is why, right? show. I'm showing, I'm not explaining. Okay, so now they want us to choose another point in the same region, right? The same region. What region is that? This region up here, right? So let's say, for instance, let's try for 400, 150. So what do we get? We get 400 square feet of gravel, right? Times the cost of $3 per square foot added to the 150 square feet of artificial turf at $15. That's going to yield us $1,200 for the gravel, and then another $2,250 for the turf is going to yield us $3,450, right? Or $3,450. So another resounding no, right? That does not meet the constraints. No, no, no. In fact, anything above this line is not going to meet our constraints. And so now that we know that this is not going to meet the constraints, all of the stuff on this line meets the constraints. What about this idea of 200, 100, right? Located to the left and below the line. Does that meet the homeowner's constraints? Again, 200 square feet of gravel at $3 a square foot, plus 100 square feet of artificial turf at $15 a square foot. That's going to give us $600 in gravel costs, plus another $1,500 in artificial turf. So looks like a cost of $2,100. So does that meet the homeowner's constraints? Well, the homeowner wanted to spend $3,000. This is less than $3,000, so I guess that meets the constraints. Right? Pick another point. How about we say, like, oh, I don't know, 40 or 400 and 400 square feet of gravel and 50 square feet of artificial turf. So 400 times 3 plus 50 times 15 is going to give us 1,200 plus 5 times 15 is 75, so it's going to be 750. And 1,200 plus 750 is going to get us $1,950 or $1,950. So that's less than 3,000. So that certainly meets the constraints. So it looks like all of the region down here, anything would work. So anything on this line and below it would work. Sound familiar from the last video? Okay, so now they want us to write an inequality, and I think we know what's going on here, right? We're looking to come in at or less than $3,000, and we want the cost of the stone plus the cost of the artificial turf to come in below that, right? We know that the stone costs $3 per square foot. We know that the artificial turf costs $15 per square foot, so there's your inequality. Don't think too long and hard about this, folks. And what does the solution look like if we were to graph it? We would shade all of this region below, and we would use a solid line. And we're saying that all of the points, right? This is a solution to that inequality because it is included. The line is included, and all of the points below. Okay, so now we're at the Saturday market, right? We got a vendor that makes $9 profit on necklaces, and the vendor makes $5 profit on bracelets. So it says, hey, find a combination of necklaces and bracelets that could sell and make exactly $100 of profit. So we want to make exactly $100. So, well, that's fine. How about we'll make $90 in profit on necklaces, right? We'll sell 10 necklaces, and that will yield us at $9. That's 10 times 9. That's going to give us $90. And then we'll sell 2 bracelets, and 2 times $5 equals $10. And at $10 and $90 would equal $100 profit. So I guess 10 necklaces and 2 bracelets yields us exactly $90. I'm sorry, $100. Is that the only combination? No. You could just have the vendor sell straight up just bracelets. At $5 a pop, 20 bracelets. 20 times 5 would give you $100. So 20 bracelets and no necklaces would give you exactly $100. What if you wanted to make more than $100 profit? There's a bazillion combinations we could do there, right? So let's talk about I don't know, just one of them. If we know that 20 bracelets gets us $100, then how about 21 bracelets? There you go. 20 bracelets would give us $105, which is more than $100. Or back to our original combination of 10 necklaces, sell 11 necklaces, and 3 bracelets, right? That's going to be more than $100. So next it says, we'll write an equation where the solution is the combination that makes exactly 100. Well, again, when we're talking about exactlies and equations, we're talking about equals 100. So it's $9 a profit for each necklace. Added that to $5 for each bracelet. There's our equation. How about the inequality where they make more than $100? So first off, more than sounds like strictly more than $100. And it's still the same front end, right? It's $9 for each necklace added to $5 for each bracelet. That's it. Now, how do we graph this scenario? Okay, now that's where I think maybe instead of 9n, we would write 9x plus 5y greater than 100. Now, the reason I chose x for, right, I'm superimposing x for necklace and y for bracelet, mostly because that's how they've already labeled my graph. It's really up to you which one you want to be x and y. It's arbitrary. Now, again, I think I want to use my intercept method. So 9x equals 100 is going to be for my x-intercept. So I divide by 9, I divide by 9, right? If y was 0, then x is going to be 11.1 approximately. And then if x was 0, then 5y would be equal to 100. Divide by 5, and y is equal to 20. So my y-intercept is 0, 20. My x-intercept is around 11.1. And then I'm just going to connect those two dots. Now, I've enlarged the graph so you can see it a little bit better. And so, again, I have my x-intercepts and my y-intercepts that I was able to calculate by thinking about this as an equation and substituting in zeros. I've plotted the y-intercept and the x-intercept, and I've attached a dotted line. So we just need to make sure, well, where am I shading? Am I shading in the region below, or am I shading in the region above? I know all of the values on the line will yield me exactly $100, but I want to yield more than $100. So remember we said that 21 bracelets would do the job? Well, 21 bracelets would be up there. And as far as necklaces go, if I sold 12 necklaces, I'd be over $100. Now think about this. What if I sold like, oh, I don't know, 22 bracelets and 3 necklaces? Where would I be? I would be somewhere around here. So all of this region represents the making more than $100. So any combination there makes us more than $100, which says that that is the correct graph, my friends. Now the last question says, is 318.6 a solution to the inequality? So first off, 3 necklaces and 18.6 bracelets. 18.6 bracelets isn't possible, okay? But is that point a solution to this inequality? Well, 3, right? It looks like we're counting by 2s on the x-axis. So 3 would put us right here. And then 18, right, I think would put us right here if we're counting by 2s here. So it'd be 2, 4, 6, 8, 10, 12, yada, 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 all the way to 18. So where is that? That's right there. Is that point in the solution set? Yes, it is, right? Yes. Explain your reasoning. It's in the shaded region, right? Sorry for the bad scribble there, but it's really tough to write on the iPad. Yes, it's in the shaded region. Or, yes, if you substitute it in here, that 9 times 3 plus 5 times 18.6 is greater than 100. Let's check that out mathematically. When you do the math, 9 times 3 is 27, plus 5 times 18.6 gives us $120, which is more than 100. But we already knew that because it was in the shaded region. So the two are verifying each other. Excellent. Okay, so this last one here, right? We're almost there. We got a band, and they're trying to raise at least $20,000 for charity by holding multiple concerts. Okay, so they want at least $20,000. So I always think about at least in terms of food, right? When I say I'm going to have at least 3 tacos, it means I'm going to have at least 3 or more. I don't know why, but anytime I see the word at least, I think of tacos. Okay, so we want to get $20,000 or more, so that's greater than or equal to $20,000, right? And how are we going to raise this money? Well, we're going to have multiple concerts, and we're going to sell tickets for $25 a pop, right? So that's money in. Every time we have a concert, we're going to have to pay money out. So this is $12.50 in fees, right? So it says we're going to write T for tickets, and concerts held is C. So I guess I'm going to get $25 for every ticket, right? That's a money coming in. Then money's going to go out. I'm going to pay $12.50 per concert. And at the end of the day, after we earn money selling tickets, lose money paying for fees, we want all of that to be greater than $20,000. So what do they want us to do now? They want us to graph the solution. And so how are we going to graph this? Well, you can write it in slope-intercept form, or for big numbers like this, you guessed it, I want to use the x-intercepts and the y-intercept. So my x-intercept, I know, is going to be some number, comma, 0, and my y-intercept is going to be 0, comma, some number. So for the x-intercept, that's going to be 25, right? The tickets sold here looks like it's on the x-axis, so 25t minus 1250c, which would be 0 at that moment, is going to be equal to 20,000. I'm just setting equals because I'm looking for an exact moment. And then for my y-intercept, x is 0, so the 25t disappears. I'm going to have negative 1250c equals $20,000. I'm just going to complete this off on the side. You should press pause and do this on your own first. Press pause now and calculate on your own. So if you didn't pay any fees, right, so you had no concerts, that's what 0 stands for, number of concerts, then you'd have to sell 800 tickets to make $20,000. Well, good luck selling 800 tickets but no concerts. People are going to want their money back. And then what happens if you didn't sell any tickets? Well, then you're going to have negative 16 concerts to raise $20,000. And again, that's kind of a weirdo thing. And then the other problem with that is I don't see negative 16 on the y. So I guess the 800 tickets will work out, right? I can plot that. So there's my x-intercept. But the y-intercept thing isn't going to work out this time. So what we're going to do is we need to know some other points. So how about we just figure out how many tickets goes with 12 concerts? Put 12 in for C and let's figure out what happens. And I'm trying to snap a line here, so I'm going to use the equation portion to figure out how many tickets goes with 12 concerts, right? So this is my C, and I'm solving for T. So 25T minus 1250 times 12, right, is going to be minus 15,000. Equals 20,000. Add the 15,000 to both sides. That's going to give us 35,000. Divide by 25. We got to sell 1,400 tickets. So we're going to follow that on the grid. And by follow that, I mean we'll follow our 12 over and down to 1,400, or 1,400 over to 12, right? And then we're going to think about our original inequality, which was 25t minus 1250c greater than or equal to 20,000. So that means I'm going to draw a solid line. So a nice, straight, solid line. Here we go. Bam. Now I went ahead and drew this up in Desmos, as you should probably try, to make sure that your stuff is correct. And that 1412 is right here, and my 800 is right here. So I think we got a good picture. Okay, so now we're ready to go answer some other questions. One of the combinations we have, just from this second dot that we obtained, right? 1,400 tickets, right? And that's going to be for 12 concerts. I should make that a T, right? That allows us to meet our goal. What else would allow us to meet our goal? Well, there's another nice point right on the line, and that looks to be about 1,300 tickets and 10 concerts. Allows us to meet the goal. But those are points that are right on the line. Now, I kind of cheated in the fact that I utilized Desmos to get that green area, but really to figure out where I should shade to the left or to the right of that line is just a matter of picking a point. Now, one of my favorite points to pick, as I've mentioned, is the origin. And so if I go back to my original 25t minus 1250c greater than or equal to 20,000, and I put in 0, 0 for the origin, right? And what do I end up with? 0 minus 0 greater than or equal to 20,000. I don't think so. 0 is not greater than 20,000. So the origin is not where I should shade. So I should shade over here. So really any point in that green area would satisfy us. Like, oh, I don't know, say like 2,000 tickets and 5 concerts. That satisfies us. 2,000 tickets and 1 concert. That would satisfy it. So now let's start going through this list here and see what we get. So we're getting a little trickier here. Which combination of tickets would be more money for charity, right? 1,300 tickets and 10 concerts. So 1,300's right here. So 1,310 concerts. Or 1,305 concerts. So 1,300 tickets times $25 per ticket, right? That's actually poor grammar for math here. So I fixed that up a little bit. We got 1,300 tickets, $25 a ticket, right? So we're going to raise $32,500. Now, if you have 10 concerts, you're going to pay $12,500 in fees. Versus 5 concerts, you'll pay half the fees, right? So $32,500 minus the fees, more fees for 10 concerts than there is for 5. So I think the one that yields more money is the 1,305, okay? How about 1,600 tickets and 16 concerts, or 1,200 tickets and 9 concerts? Well, I'm looking at the graph location, so I color-coded this. The purple spot is the 16 concerts and 1,600 tickets. The red dot represents, I had to bury that for a second, but this is the 1,200 tickets and 9 concerts. First off, this is not even in our solution set, which means it didn't even yield us $20,000, whereas this one's right on the line, which means that we yielded $20,000. So I don't even need to do the math. I know that the 1,616 concerts is the winner there. The last choice here, 2,000 tickets, 4 concerts, 2,500 tickets, and 10 concerts. Now think about this for a second. At $25 a ticket, just 500 more tickets, it's only $12,000. That's an additional 6 concerts. So 6 times 1,250 is going to be 7,500. It's going to be a close race. Let's plot these out first. Okay, so the first set, 2,000 tickets and 4 concerts. Just for the record, 2,000 times 25 is going to get me $50,000 in ticket money. And then 4 concerts at $1,250 a piece is going to yield us $5,000 in fee costs. And when you take the $5,000 away from 50, you get $45,000. All right, let's take a look at the 2,500. And now the 2,500 ticket 10 is way deep in the green over here. that $2,500 tickets is going to yield us $62,500 in ticket money, $12,500 in fees from having 10 concerts, yields us $50,000. $50,000 is greater than $40,000, so I guess we have ourselves a winner. Circle in the purple. So in closing, inequalities in two variables can represent real life situations, and graphing their solutions can help us to solve problems, right? Suppose a cafe is purchasing coffee and tea from a supplier, right? They can spend up to $1,000. You got coffee beans and tea leaves, right? They're buying C pounds of coffee and T pounds of tea leaves. You got 12C plus 8T, right? They don't have to spend 1,000. They could spend up to 1,000, so less than or equal to, right? The solution to this inequality is any pair of C and T that makes the inequality true. So any combination of C and T that gives you exactly 1,000 or less, right? Now down at the bottom it says, hey, listen, we could try different pairs. Right? We can try different pairs of this thing to see what combinations satisfy, but it would be difficult, right? It would be difficult to capture all of the possible combinations. And so what's easier? Instead, to graph it, right? To graph the solution would find the region that represents all the possible situations. It's a much more powerful way to go about it, right? So when we look at things like this, we start to think about which ones work. We see the 2040 is below the line, right? Point 2040 is below the line, and it yields a true situation. 7100 is above the line. That reveals a false situation. So that's not where we're going to shade. Our solution is down there, which yields us a nice graph like that. So any combination, say, that's in this region, right? So right about here, that would represent 30 kilograms of coffee beans and 20 kilograms of tea leaves. That would yield us a solution for this inequality. And that would yield us a cost that would be less than what the cafe was looking to spend. Anything that lands on the line would be exactly $1,000. In closing, make sure that we understand how to interpret points and decide if they're solutions graphically or algebraically, right? So by substituting in, looking at a picture or substituting in. Make sure that you can find solutions to inequalities by using the graph, right? And make sure that you can write inequalities. Now, move on to the cool down.